Hey ROS developers, Marco Arruda here, and today we're going to start this new series which is about developing web interfaces for ROS. So in order to start it, I'm going to use as usual the ROSJect, ROS Development Studio. If you don't have an account yet, you can start using it just for free, create your account, and you can use the same account to use the RobotNet Academy and ROS Development Studio, everything inside the construct. So let's get started. For this first video, I have already created a ROSJect, which is, actually I don't have any code there yet, but I have this notebook, which is going to provide me some instructions to configure this very first moment. We have to configure the environment to create a web page, and then I'm going to explain how this web page is going to interact with the ROS environment we're going to have in our project. Okay? So I'm going to open it, and let's wait a few seconds until we have everything prepared. In the meantime, why have I chosen this specific subject to work with ROS? Basically, this is one of my specialties, and something that I think it's very exciting actually, which is the power to interact with hardware and robots and then ROS through a website. Why a website instead of native applications for mobile phones and so on? Well, because websites you can access them either for working with a desktop or with your mobile phone, or maybe you're working with a tablet or any kind of device that you have access to the internet. You may have a web browser on it. So this is why we have chosen this kind of technology to develop interfaces for ROS. Okay, so no matter if you're working with ROS for industrial applications, for static machines, or if you want to control your drone, or maybe just a wheeled robot, or maybe a manipulator, it doesn't matter, because the way we're going to follow this video series, we're going to be able to interact with all the metadata that ROS provides to us. And when I talk about metadata, I'm talking about ROS nodes, ROS topics, ROS services, and ROS parameters, action servers, and so on. So everything, any kind of information that you have inside a ROS environment, they are going to be available in our web page. Okay, and that's why I think this is going to be amazing. So let's start it. Just before we have the ROSJect open, I'm gonna get back to my ROSJS main page. And also there's something else I would like to explain, which is about RobotWebTools. So this is not something new from the construct or from me. This it's not something that I'm inventing from the spot, but actually this is something very important, and there is already a community around this subject. So if you want to check more references about this, you can always come to this webpage here, robotwebtools.org, and you can check. There are many tools, libraries, widgets, systems, and server-side stuff available to work in web for ROS. Okay, and one of the libraries we are going to use is this ROSLIBJS, which is the library responsible to make all the ROS data available in our JavaScript code, and this is what we're going to use to get all this data and to send commands to ROS. And in order to have all this data available to the JavaScript library, we are going to connect to a server-side tool that is called the ROSBridge suite, okay, which is another library. And this one goes on the server side. This one is responsible to provide all this data to the JavaScript libraries. Okay, so let's get back to ROSJS, and here we are. I'm going to start opening my Jupyter notebook because I want to have the instructions just by my side. Okay, so let's start opening a shell, and what are going to be the steps that we have to follow in order to have the environment configured for this first moment. Basically, we want to have a web page that is going to be able to interact with the ROS environment, And secondly, in order to connect to ROS, this web page needs to have the ROSBridge server running, and this is going to be configured in our website of ROSJect, and something that you can also run in your local computer. And finally, we are going to run a simulation just to have a robot available, so we can send commands from the web page to the robot, okay, using ROSBridge as well. The name itself is very explanatory. It's going to be the bridge between the web page and the robot simulation. It could be also a real robot, but for the sake of simplicity, I'm going to use just the simulation this time, okay? So let's get started. Through the IDE, I'm going to create a very simple web page here. Actually, I have some files here already. I'm going to remove them and create from the scratch, okay? Every project created in ROSJect, they have already some workspaces here, like the AI workspace, casting workspaces, datasets, notebook workspace, and the simulation workspace. We're not going to use them, but instead I'm going to create a new one here, and I'm going to call it Web Pages, okay? And just inside the Web Pages, I'm going to create a new file, but now I'm going to use the IDE, because this is very useful. So new file, and as any regular website, any regular static website, which is the kind we're going to start from, you need to have an index.html file. That's why I'm creating this right now. I'm gonna put some instructions here. I am supposing that you have just some basic knowledge of web, but I'm not doing anything advanced here. So if you have doubts, you always have the comments area just below the video, and you can ask whatever you want to follow this video tutorial, okay? So basically we have the head of the file and the body where we're going to put the content of the web page. And for this web page, I just want to put a nice title here, which is hello from ROSJect. And this is going to be the type of my page, okay? And I want to communicate to robots from my first web page. So this is going to be the content of the web page. It's quite simple. And now the next step, I want to access this web page from my browser. After all, I'm using everything from the browser here. I just want to open a tab and open this new web page right here. I want to access the web page here. So how can you do this? Now that's the first moment we need to go back to the notebook. Let's check there. In order to do this, I'm going to use a very simple HTTP server based on Python 3. In order to use Python 3, since I'm working with Ubuntu 16 and ROS Kinetic, I need to configure a virtual environment, and it goes like this. I have to create a virtual environment. I'm going to call it venv, and it's going to be based on Python 3. Okay, so you can just copy and paste, press enter, and it takes a few seconds until we have our environment ready. The next command we have to execute is the source, because we want to use Python 3 now as our libraries. And if you execute which Python, you can check that now we are using Python from this virtual environment. Okay. Now we can just go to our web pages folder, and from there, just execute the HTTP server, which is the one in charge of publishing, making available this web page, this index.html file, accessible through the internet. And how do we access this? It tells us that it's available at this local host here in port 8000, but actually this is not accessible from any computer in the internet. Instead, I need to know which is my public IP. In order to do that, you have an alias, very convenient for ROSJS. You can just type public_IP, press enter, and there it is. This is your public IP. For sure yours is going to be different than mine, so you have to execute the same command and get yours. So just go to the other tab and put the public IP, the number of the port, and there it is. So we have our static page. Okay, we have the title, we have a simple text here, and from this moment I think it's very important, if you're not using it to develop for web, and maybe you're not using it to the debug tools for web development, I like to use Google Chrome, but you may find very similar tools if you're using Firefox or Opera or Safari maybe. But the most important tool we have here in order to debug our web pages is the element inspector. So you can just right click on the page and choose here inspect. You can also use the keyboard shortcut, which is F12. Okay, and then you can grab it here to the right side of the page and you can check the console. In this case we have just an error telling us that we don't have any icon for the page, but it doesn't matter, it's not important for now, so you can just ignore this error message. Okay, let's get back to ROSJS, and there it is. Let's check the next steps. Okay, so now that we have the page accessible through the internet, I want to have also a simulation running in my environment. So it's going to simulate a real robot. In this case, I'm going to use TurtleBot2, which is a very simple robot, very static, and most of ROS developers are already used to work with this robot. So I'm going to just choose the robot here and start the simulation. It should take a few seconds until it gets ready. Okay, so for instance, I'm going to put the simulation to the right corner here. We're not going to use it for now. Okay, and a very important step, as I explained at the beginning of the video, we have a web page. We have also the ROS environment, and in the middle of those two elements, we must have the ROSBridge, which is the server that are going to provide the ROS data from the ROS environment to the web page. So how can we have this ROSBridge available? Let's go to the terminal, and this is something that is already installed in ROSJS, and you just have to launch it. So it goes like that, ROS launch, and actually this is a command that I have also in the notebook if you want to just copy and paste. Okay, so it goes like that, ROS launch, ROSBridge _server, and ROSBridge again _WebSocket. ROSBridge server, ROSBridge _WebSocket. Okay, there it is. And just press enter. And we may have the ROSBridge server running in a specific port. It's gonna tell us which port it's running. So at this moment we have the simulation ready, so you can see the robots just there. Stop it. Okay, waiting for the commands, and we have ROSBridge being started. Let's put it a bit bigger. And I have ROSBridge WebSocket running on the port 9090. So just copy the number of the port, and the public IP is the same. Okay. So at this moment, we have already the three elements available. So we have the web page, we have ROSBridge running, and we have also a ROS environment already configured and running, which is the simulation. So the robot is already there. It's available to be programmed, to receive commands, and also providing sensor data for us. Okay, so let's get back to the notebook, and I'm gonna just copy and paste this basic code to my web page. Okay, but it must be inserted inside a script tag. So this is something also very specific to web development. If you are not used to work with web development, you can always ask questions in the comments area below the video, okay? And then I'm gonna just copy and paste, and I'm gonna explain line by line what we're doing here, okay? Let me indent the code, so now it's more or less organized, okay? Nice. And there is just one more thing that we need to have just before we run all these commands here, which is the necessary libraries. So basically, we're trying to instantiate this ROS object inside the page, but if you save the file and you get back to the web page that we have provided, just reload it, and you are going to notice that we have a different error message right now at this moment, which is about reference error, and we are trying to reference something that is not defined in our page, which is ROSLib. And actually this is fair enough because I haven't included the necessary library. So for this reason, I'm going to get back to RobotWebTools. I'm going to access the ROSLIBJS page, and you can just take the CDN, the minified file. Okay, so I'm going to copy this address right here. You don't have to copy all the code. Actually, if you want, you can do this, but I'm going to choose the simplest way. So just copy the address here, and in our head section of the HTML file, I'm going to put another script tag, but this time I'm not going to place the code inside the tag. Instead, I'm going to put the source of the code, which goes like this. So I just copy the address that we have access from here to the code, and this is not mandatory, but I like to specify this is a text type JavaScript. Okay, so save the file again. Let's try to reload the page, and let's see what we have. Okay, so we still have an error here, but a different one, so it's a good sign. So WebSocket connection failed. Very nice. Now let's check it line by line what we're doing there. Basically, the robot still stopped it. Let's minimize the shell, put the simulation to the right side, a little bigger. Okay. And check line by line what we're doing here. So basically I'm trying to access just an awkward IP, and of course this is not real because I put on purpose there. So I have to copy the same IP I'm accessing the page. Okay, so just copy and okay, paste it here. I have to fix because when I copy the IP from the web browser, it autofills already the HTTP protocol. So just remove it. And now we have the public IP of our computer and the number of the port 9090. Which I have took from this web shell here, so it is specified by ROSBridge server. Okay. Finally, so we are defining the ROS variable, which is the object in charge of communicating the web page to the ROSBridge server, and we have some hooks here. So let's say we have some callbacks, and they are going to be called on these specific events. So at the first moment, if you have a valid connection, we are going to have this message here being printed in our console. So connect to the WebSocket server. If you have something wrong, we are going to have this message, so ROS on error. And if the connection is closed for whatever the reason, we are going to have the close event and receive this message in our console. Okay. Finally, I want to move the robot from our web page, and in order to do this, I have to create a new topic. Actually, I'm creating a new publisher to an existing topic already. So if you open another web shell here, if you already use it to work with Kobuki and other ROS robots, you know that CMD file is, in most of the cases, it's available to move a robot. But let's check here, and we have command velocity, just right here, okay? And if you check the ROSTop type of the CMD file, you're gonna see this is a geometry message twist, okay? So this is why I'm using here, we are declaring a ROSLib topic, a publisher to the topic CMD file, and the message type comes from geometry messages, twist message, okay? So this is the publisher, and now we have to define the message that we want to send to the publisher, okay? So it goes like that. We are defining a new message twist, let's call it the name of the var, and we have from ROSLib a new message. This message goes like an object, and I am defining the attributes of the object. It starts with linear and angular, and you can check also why am I defining this message like this. So let's check ROS message show geometry messages twist, and if I haven't typed anything wrong here, we may have a description of the message we want to publish. So there it is. For geometry messages, we have a first attribute, which is called linear, and we have 3 attributes beneath x, y, and z, and the same for its brother, for its sibling, angular, x, y, and z. Okay, so that's why I'm defining linear and angular. So in this case, I'm putting some linear velocity to the robot, so we have to go ahead, and some angular velocity around the x-axis. Actually doesn't make sense, so I'm gonna change to the z-axis in this case. Okay. Finally, we have just a console log instruction here to show the console that we are about to publish the message to the robot. In this case, I want to show what is happening here. So I'm not just waiting the robot to move, because this is what we're expecting to have from this web page, but also I want to show the messages that are coming. So how many messages are coming? Is it happening just once, or are we defining a publisher with a specified rate? Actually, we are not, but let's make sure we don't have, okay? So let's do a ROSTop echo CMD file, and we are going to receive any message that comes to this topic. So we have the web page ready. Let's get back there and reload the page. Okay, so we don't have any errors here, and we have the message publishing CMD val, and we are connected to the WebSocket server. So it's expected that we have received at least a single twist message. Okay, so let's check here. Okay, very nice, the robot's moving. And what do we have here? So just a warning, because the message just took too long to start arriving to this topic, and we have just a single message with linear and angular attributes, and we have exactly the same values that we put in our page. Okay, so from now you can do some tests. For example, I want just to stop the robot, so I'm going to put everything 0 here, and as you have already noticed, the web page is not going to be executed just because I have changed the values, of course, because I have to reload the page. So no new message has arrived, but now I'm going to get back to the page, reload it. We have again the same console messages, and the robot is stopped. Okay, so we have just received a new message here from the web page. Okay, well, basically that's it for this first video. We have already seen how we can, and now we know that it's possible to send messages from a web page using JavaScript and through ROSBridge to a given ROS environment, since you have everything connected, and in this case we have a public IP. But if you don't have one, and maybe if you just don't want to make your robot available and your ROS environment available through the internet, you can just use a closed network and so on. This is not gonna be the focus of this web series. Instead, I'm just gonna focus on how to develop web interface for ROS. So in the next videos, we're gonna see how we can check the topics that we have, and how we can create more useful buttons to interact with the robot. After all, right now what do we have? We just have a page and we have to change the code, and then we load the page to send different messages. So let's improve it a little bit in the next video. Okay, so that's it for now. I hope you liked the video. If you didn't, please leave your comments and let us know how we can improve this kind of tutorial. See you!